Remember that there are two main forms of statistical inference, estimation and testing. In this lesson we'll take a look at estimation. This will be our first look at it, and we'll have several more lessons on estimation. Let's begin this one with a simple example of the kind of thing that we're all familiar with. Suppose that you need to drive from Klamath Falls to Ontario, Oregon, and you've never done that before, and you want to know how long you expect that to take. So you might find somebody who's made that drive on a regular basis, maybe somebody like Jimmy Merkley on his way home to Pocatello, Idaho. And so Jimmy would pass through Ontario most likely on his way and might have some idea how long this trip would take you. So you go and ask Jimmy, how long is it going to take me to get from Klamath Falls to Ontario? And he might give you an answer like something like 8 hours, give or take a half an hour. So what Jimmy's done is he's just given you an estimate of how long he thinks it will take you, but there's some possibility of error, of maybe his estimate being off by a half an hour one way or another. Now, he's based that estimate on his experience driving to Ontario, which we could look at all the times he's driven from Klamath Falls to Ontario as being a sample out of the population of all times anybody's driven from Klamath Falls to Ontario. So this is an example of estimation. It's statistical inference. He's using his experience, and we're inferring that his experience would be roughly the same experience anybody else would have. Let's draw. It's oftentimes helpful with estimation to draw a picture. Let's draw a number line here where this is going to be time in hours. And let's put 8 hours right here. That's Jimmy's estimate of how long it would take to get there. Let's see, let's put 7 hours over here and 9 hours over here. And the fact that he's said give or take a half an hour means it could take longer than 8 hours, maybe a half an hour longer, which would put us up here at 8.5 hours. Let's put a parenthesis here. And over here let's put one at 7.5 hours because he says give or take, so it could be even less than 8 hours, maybe 7.5. And these two parentheses then indicate a range of time values in which we think your trip from Klamath Falls to Ontario might lie. So it might be in the range from 7.5 to 8.5 hours. So you'll notice based on the picture that Jimmy, instead of saying 8 hours give or take a half an hour, could have estimated the time it would take to get from Klamath Falls to Ontario in a different way. He could have said it would take between 7.5 and 8.5 hours. So these two are conveying the same information, but what we have some specific language we'll use. The 8 hours that he gave is something that we'll call a point estimate. And what it means is that his estimate is actually a single point. That 8 hour estimate is a single point on this number line right there. This estimate here is what we call an interval estimate. Okay, so we have a point estimate of 8 hours, an interval estimate of 8.5 or 7.5 to 8.5 hours. Now, when we give a point estimate, we need to indicate the error, and we do that with this thing here, which is usually called the margin of error. Occasionally it's called the maximum error, but we'll usually refer to it as the margin of error. So we can give our estimate as either a point estimate with a margin of error or as an interval estimate. And it should be clear that if we have the point estimate and margin of error, we can get the interval estimate by adding and subtracting the margin of error to and from the point estimate. If we have the interval estimate, we can find the point estimate. It will always lie or at least for most things that we're going to be looking at, it will lie halfway between the two endpoints of the interval. And then we could find the length of the interval, which in this case is 1 hour, and divide it by 2 and get 1/2 hour. So the math for that, the arithmetic, it's not terribly difficult, but if we have an interval estimate, so in this case we have an interval estimate of 7.5 to 8.5, and if we were given that information, we can get our point estimate by finding the value halfway between those two. And we've talked before in this course how if we want a number halfway between two numbers, all we have to do is average those. So the point estimate in this case is obtained by taking 7.5 plus 8.5 and dividing by 2. 7.5 plus 8.5 turns out to be 16 over 2 is 8 hours, the point estimate. And then if we want to know the margin of error from the interval estimate, all we have to do is figure out the length of the interval. So the margin of error is the length of the interval, 8.5, in this case minus 7.5, and we divide by 2. So 8.5 minus 7.5 is 1, divided by 2, which is 1/2, or 0.5 hours. Or we'll say 0.5 hour. So that's how we take an interval estimate and determine the point estimate and the margin of error from those things. And it should be clear, but let's do an example. Let's look at a different example. This is an estimate of a mean. Actually, this would be the average time it takes to get from Klamath Falls to Ontario. So let's look at an estimate of a proportion. Suppose along your drive from Klamath Falls to Ontario, just to kind of kill time, you decide to look at all the cars that you either pass or pass you, going the same direction as you, just to keep it from not being as many cars as it would be if you took the ones going against. And you decide to look at all the cars and find out what proportion of those cars on the road in Eastern Oregon are actually pickup trucks. So maybe during the course of your drive, you find that the cars that you either, or the vehicles you either pass or that pass you, maybe there's, during the course of your trip, there's 37 vehicles, and you might find that 23 of those are pickup trucks. Let me grab my calculator. So if we take that proportion, 23, so let's see, clear, 23 divided by 37 equals, so we get 0.6216, so let's just say that's about 62%. So we might then estimate, based on just our experience on that trip, that 62% of the vehicles on the road in Eastern Oregon are pickup trucks. I'm not sure I made that look any better. And then let's say, we don't know how this happens, but suppose it wasn't just you. Suppose somebody actually is gathering this data and they get that 62%, but they maybe get a margin of error of 3%. So we could say 62% are pickup trucks with a margin of error of 3%. Now, I'm just making those numbers up. I have no idea whether those are reasonable or not, although Eastern Oregon is fairly rural. There are many, many ranchers and farmers out there, so we would expect to see a lot of pickup trucks. But the point I want to make is this. So we have the 62%, which is our point estimate, and we have the 3%, which is the margin of error. So let's figure out what our interval estimate is, and let's do that. Again, we'll just draw ourselves a number line, and we'll put 62% here. Okay, so this is a proportion rather than a mean. The units are just percent. And if the margin of error is 3%, then that means we go 3% this way and 3% this way, and that shows us where we could reasonably expect the true percentage to perhaps lie. So if we go 3% this way, that's 62% plus 3 is 65%. 62% minus 3% would be 59%. So the point estimate of 62% and the margin of error of 3% give us an interval estimate. Oops, lost a letter in there. Let's get it in there. So we have an interval estimate of 59% to 65%. So we've looked at, we've seen the basic idea of of how we do estimates, and we've seen the concept here of a point estimate, margin of error, and interval estimate, and how those three are related. So in the next lesson, we'll move on and see these estimates are, when we do the interval, it's actually called a confidence interval, or we talk about estimating with confidence, and in the next lesson we'll see what that means.